My name is Jon Karam. I'm with DelDOT North District Maintenance. I previously worked in bridge design for 8 or 9 years, and I've been in this position now for about a year. And I'm going to speak on DelDOT's recent CMP lining successes. So here we have our mission statement, as we're supposed to include in every presentation. Here's our agenda. So we'll cover the CMP repair methods that we have available. We'll specifically get into spray-applied pipelining, which is the bulk of this presentation. We'll discuss a couple pilot projects, some research that we performed, a pipeliner bundle that went out to bid, and some future projects that we have. So some CMP repair methods, as you may know, first and foremost is going to be a full replacement. That's going to give you the best quality, brand new bridge. That does require typically a full closure. It's going to be your highest cost, and you're going to have a lot of impact to the public there. You do get an increased hydraulic opening, which is a benefit for full replacement. When it comes to spray lining, it can be used on any size pipe. So you'll see in this presentation that we had a very large CMP that we did use this on with success. There's no closure or impact to the public really. We may have a shoulder closure. Other than that, you don't need to rip up any of the road. It is quite cost effective, and it does decrease the hydraulic area, but you do gain a better Manning's value from that. So CIPP is also another option. This is more so for drainage pipes. It can be used for small bridges, 5-6 foot culverts, but typically we're not going to use this for a large elliptical culvert or a bridge size pipe. So I'll cover what spray applied pipelining is. So it's a fiber reinforced mortar that they use to structurally rehabilitate the culvert. Like I said, no diggings required. It has a design life of 75 years, and it is an alternative to CIPP or slip lining, and can be used for bridge-size structures, drainage pipes, etc. So when would you want to use spray-applied pipelining? So we've used it for single-access bridges where it's just one-way, dead end. Utility conflicts, which you'll see in the next couple slides on a pilot project that we did. If you have extensive traffic, MOT, or a very long detour that you have to implement, you may not want to use a conventional method of replacing it. Also cost is a factor, and then you have horizontal, vertical constraints if you have to raise the road or anything like that may be an issue, as well as staging right away, typical issues there. So here are some other pilot projects that we did complete. We're going to cover and focus on 1-238 and 1-657. One was done with a cementitious liner called Storm Seal. The other was a geopolymer called Geospray. So the first location is Bridge 1-238. It's actually at a cul-de-sac. It was two 6'9" by 4'11" CMPs, 110 foot each. And like I said, we used the cementitious. We had utility issues out here, and it would have cost more to relocate those utilities than to even replace the pipe if we did go that route. There's limited room for staging, no detour as it's a cul-de-sac. So here's a small little screen grab of some of what we were dealing with. So the utilities actually run both directions, so it goes around the entire circle, and then you have it crossing the pipe in two locations. So 3 underground cable lines, underground electric, sewer line, water line, and then you still have to maintain access for the people that live in this cul-de-sac. So we ended up using the spray lining. You'll see in the next photo that here's the before and after. There was some challenges to get to the point that you see on the right where the finished product is. So when they initially did the spraying, we had some leakage and it wasn't fully watertight. So they had to come back, continue spraying, and it took much longer than it should have. But in the end, we did get an acceptable product here. So the next pilot project is Bridge 1-657. This is on Route 13 and 40. It's actually at the split, and it was two 48-inch by 72-inch CMPs, 250 foot each, and that was the geospray material. We did some concrete cloth work as well for scour countermeasures, testing that out. And you'll see in the next photo that we have, the pipes are shown in red. We have a buried gas line out there. The existing drainage pipe actually ties in and runs underneath that development there. Gas stations around. We have railroad, which is always going to be a mess to deal with. And you have a lot of horizontal, vertical constraints. So if you did want to do a full replacement here, you'd most likely have to raise the road and chase, to get to that standard that you need now. So this one we decided to use the geospray material. We hadn't used it before, but we thought this would be, the perfect situation, just because if we were going to replace a location like this, I mean, it could be $5–10 million in cost for, something like this with all the utilities, the businesses, everything involved. So you can see the photo on the left. Can't see much, but there's the CMP there, and then in the photo on the right, we completed the lining. So we did get involved with some research. So there was a pooled fund study with other DOTs. You see ODOT on there, New York, Connecticut, North Carolina, Minnesota, Florida, etc. So they did, develop a structural-based design, and that's kind of what we've updated our spec to reflect. And there is some language about a performance-based spec, depending on what strength you are getting from the material, that may dictate the thickness of the material in the end. We also had University of Delaware participate in some research for us. We did some in situ testing out there, so we did a load test before and after, and we did see an improvement in the rigidity and structural performance of the pipe after. NEPTEP has their own testing that they've done as well, which we've reviewed and kind of incorporated into our spec. So here's the specification. So once we did those first pilot projects, we kind of sharpened our pencil a bit, and now we've kind of went through the research, and now we're at the point that we could update our spec to make it the strongest possible. So we updated our unit of measure and made it easier to track from a square footage standpoint. We had a detailed work plan, and we included this detail here, a figure to fill in the corrugation. So per the manufacturer, they weren't actually saying you have to fill in the corrugations, but in our case, we wanted a smooth lining, both from the hydraulic standpoint of having increased mannings or decreased mannings there, and also to have a better product overall. So we have a pipe liner bundle that we went and moved forward with. So it's these 3 bridge locations here. We had our consultant Pannoni help us out with the design. The contract was awarded to JJID under the low bid. It was around $2.2 million for all 3 locations, which included scour countermeasures. So you'll see, but we could have spent that $2.2 million at one location if we did a full replacement. So it was a cost benefit with using the spray lining. We had NTEC as the subcontractor with the geospray, and we started it in early January of 22, and we finished in end of February of 22. So it went very quick, and we were satisfied with the results. So we have Brick Mill Road 1-406. So it is a low ADT area, but we did have utilities, aerials that we had to work out. I don't think that the detour was great for this spot either. So we ended up lining 3 CMPs here, 14 by 3 by 8 by 11, and it was almost a roughly 3-inch liner thickness. So here are the 3 pipes, as you can see. And then we have some of the before photos of the existing structure. You can see they actually were able to put the hammer through the culvert itself, and you have a lot of rust right at the water line. So here's a photo during construction. We had a full stream diversion in on both ends, and then we were able to come in, repair the pipe as needed, and start spraying. So as you can see, the completed liner, it looks like a brand new concrete pipe. That's kind of the intention of this. It's supposed to be standalone, so even if the metal CMP rusts out and you have nothing left, you now have a new concrete pipe inside of that, which should bear all the load. And then here was the finished product there, so turned out good. I don't think we had too many issues with it. And this probably took like 3 weeks to do the spraying, so 1 week each pipe. They're quite long, and you have 3 inches of material, so it's a good bit that they had to spray. So the next one is actually the largest of the bundle. So this is Bridge 1-242, Red Mill Road. It sees about 24,000 cars per day, which is not extremely high, but for a road like this, it is pretty high. And it is a route for school buses and whatnot. So we actually had 2 aluminum CMPs. They were almost 17 foot by 10 foot, very large. And we ended up with almost 3.5-inch liner thickness for this. So likewise, we had utility impacts that we had to worry about, a lot of traffic impacts that we would have had to do if we wanted to do a full replacement here. And then, full detour as well. So you can see these are the pipes here. There's quite a bit of water. It actually feeds from the Christina River, so it's a sizable volume that comes through here. And we did put in some scour countermeasures, which consisted of R7, so that kind of gives you an idea of how large you need the riprap for the velocities out there. So here you can see it's an aluminum pipe, and once you begin seeing that those white, corrosion stains from the top of the pipe, then you know that it corrodes from the outside in. So once you start to see those, there's a problem and you need to do something. So here was the completed liner. Looks great, worked out well. We didn't have too many issues. I think just with the initial coat, due to it being aluminum, we wanted to use a primer, and that's something we did incorporate when we lined the second pipe out there. So we have a nice smooth finish, as you can see. It looks like a brand new pipe, so that's the goal for this. And here was the last one of the bundle. So Bridge 1-362, this is Library Ave in Newark. So you have decently high ADT, 32,000. It gets even higher during the school year. So the summer is going to be lower, but during the school year, because it's right near University of Delaware, you get much higher traffic volumes. So it's about 10 foot by 7 foot CMP, just a singular one, and it was 2.5 inch. We're close to that thickness wise. Had we done the full replacement, we would have had utility impacts to worry about, pedestrian traffic, so we were able to save money with going this route as well. So here's the existing. It actually had an asphalt tar coating on it, and we instructed them to remove 90%, of that coating, so we would get a better bond with the geopolymer being applied. And I'll actually talk real quick. We actually had to cut out a portion of the bottom of this pipe because it was heaved, and we ended up pouring flowable fill as a base, and then we did the lining. So typically you want to get rid of any infiltration or any voids, whether it's using like a flowable fill in the bottom or hydraulic cement in the sides, or even like a Urotech grout like they had presented on right before. So here was the final product, and you can see it looks pretty much like a brand new pipe again, and we'll see how long these last. Hopefully we hit our 50 to 75 year design life, and then we don't have to come back to these locations. So we did have some lessons learned from this. You always want to perform your H&H analysis prior to lining, so that kind of dictated whether or not or how thick the lining could be. So, when we ran the hydraulics, it came out to, okay, 4 inches is the max lining that you can do before you're going to have adverse effects. And, so our design for the lining was 3.5 inches, so we were okay there. But you do want to check your hydraulics, make sure you're not going to cause any additional scour downstream or, back up anything upstream as well. The contractor, the subcontractor needs to submit design calcs. They need to be PE stamped, so they need to go through the design. They should provide that to you if you are choosing this method. And the big thing is getting your spec to be strong enough. There's some materials that aren't as strong as others or perform as well as others, and you want to avoid those and try to get something that's going to be kind of true and trusted. It's going to meet those flexural strength requirements. The GeoSpray that you saw on here is about 1,200 for the flexural strength, which is what the design is going to be based on. So the lower the flexural strength, the thicker it has to be. The higher the flexural strength, the thinner the liner can be. And you want to have an approved work plan. So the contractor should submit that prior, to doing any work out there. Tell them what, we're going to use for thickness indicators, how you're going to track the thickness, making sure it's a uniform thickness, and then addressing any, section loss or, cleaning that needs to be done, like that asphaltic coating. So you have to do your prep work, make sure you get a good clean pipe, fill in most of the voids, and then you can start lining. We did have the lab come out there and they did test, and we did achieve higher strength than what was actually spec'd, so that was good. We didn't have any issues with the material. Once you spray it in there, you're kind of stuck with what you got, so you could spray more if you do get a lower flexural strength. In this case, we were okay and we were able to accept it. Like I said, it needs to meet the requirements in the spec, and you want to have the thickness indicators. So you see in that photo they have a nail driven in with piano wire that they measured 3 inches or 3.2, whatever the design thickness was going to be. That way they could, once you get to that point, you can cut the piano wire and you know that you're at the thickness that you need. And then, of course, post-inspection, you want to make sure you're inspecting the pipe. Luckily, these were easy enough to walk through, being large enough, so you could see every defect if there were any. And then we did do some thickness spot checks. So if you do have an issue where you don't think it's reaching the thickness that was designed for, you can drill in and then put a thickness indicator in there to see what you actually have in the end. So we have some future projects coming up. Bridge 1-133 in Breidablik Court, and it's a single access road, so pretty much dead end, and this was decided that it would be the best route. So this came from Bridge Design. They provided the plans, and we're going to take care of this through maintenance. We also have a bridge bundle. I think Jason may have mentioned it in his presentation yesterday. So it consists of 9 locations, and we're looking at whether we can spray line, slip line, depending on the H&H. And we are looking at some other products, like there's a polyurethane spray wall, and that's much thinner, and it does look promising from strength standpoint. The issue is it has to be pretty much completely dry in the pipe to start spraying that stuff on there. So something we're looking into. We'll kind of decide when and where it makes sense. Until then, we'll probably continue using the GeoSpray or equivalent strength of that. So that's my presentation. If you have any questions, you can email me or ask me now.
Thanks for the presentation. I have a question on the analysis that the contractors did. Did they do like a finite element analysis, and were you getting LRFR ratings and LFD, or what were you getting in regards to that?
We had our research team with UD. They did some finite element analysis, but it does use the distributed beam method for the actual design of the the lining thickness.
And then you were getting LRFR ratings as a result? Or?
I'm not sure exactly what we ended up using for the load rating in the end. Maybe
Okay.
bridge management's able to,
Okay.
talk more on that.
Okay, thanks for the presentation.
Was there a particular threshold you had in mind for the section loss?
There's ways you can repair it. So, I think I've seen it before. They use like chicken wire and then they'll spray around that and try to get, you really need the shape. So if you can maintain that shape, and like I said, we had to cut out the bottom into one because it was heaved up a little bit. But ultimately, we put the flowable fill, and that we still had the full elliptical shape there.
Thanks.
So,
John, thanks for the presentation, really good. Quick question, were you concerned about any kind of infiltration through the top, like Tim was just talking about? And do you say, well, if you have that, you don't go this method because you have to do something on the outside to kind of stop that flow, or?
You can. I mean, you could use like the Urotech, or we actually pumped the hydraulic cement from the, into the sides, and that kind of filled in those voids. I think that case was kind of a special one because we had like a spring or something that was bringing water that shouldn't have been. But yeah, you could use the Urotech from either up top, or you could inject hydraulic cement through the sides.
Any specifications or qualifications for the contractor? Seems like a close cousin of shotcrete.
Yeah, it is very similar to the shotcrete. The company that we had, Entech, has 20, 30 years of experience or more. I think our spec requires 5 years of work that was done properly, so they needed to have that, as well as some additional requirements in there. I don't have the spec with me right now.